Hi, this is the Energy Conscious Workout Machine project. My name is Anthony Conti. I'm an electrical engineer.
And my name is Logan Reamer, and I am another electrical engineer. We started out this process by thinking about the problem of that the average American expends a lot of energy, and that process is very abstracted, meaning that you don't really know where your energies come from or how much effort it takes or what the processes are that actually generate those energy. And it also came from the other idea of working out and that process itself expends a lot of energy. So if we could kind of combine those ideas in your head to how much you are working towards and then what that could actually produce in your home towards something useful was the whole idea. And so our solution to this is a device that is both a teaching tool, like we had said, on how much they use in their daily lives. Our machine converts electrical energy to, or mechanical engineering energy to electrical engineering using some electromagnetics and spinning this wire across some magnetic device, which is how generators work. Our process uses a motor to achieve this process, and it currently tracks calories burned versus watt hours generated as its primary metric. And once again, just the overall idea was to give the user a sense of how much effort and work it takes to produce our electrical energy that we use in daily life. So, what did I do? I was primarily in charge in the construction of the mechanical device, as well as the heart rate sensing and power sensing. And so, what does that mean? The first thing in terms of the construction is 3D printing. I 3D printed the handle. The handle had to be hollow so that it could, all the wiring could exist inside of it and contain the heart rate sensor. Then the mounting of both the item to the ground and to the handle and the motor so that you could actually spin it around. And lastly, a little bit of manufacturing in terms of it was already hollow, but creating the holes to run everything through. And so what came out of this problem-wise was stress testing. We had to make sure the handle could withstand the force of use during a workout, which is normally a pretty intense event. And that was done just by using and squeezing this handle far harder than you would expect to, or it could be reasonably used. Compactness was important because everything had to fit inside of it, and it had to be useful as a handle that you could actually spin around. And this was just done by some scaling and some careful choosing in the actual model phase. And lastly, the coupling. This is the part that was succeeded on the least amount, but is just screwed into a piece of wood and then screwed into the motor. But if you wanted to continue on, you could continue this with actual couplers or fittings with some mechanical engineering. Next, I did the heart rate sensing. The heart rate sensing detects over a certain intensity threshold, which registers it as a heart rate, and then it stores that last minute of value to calculate your BPM, and then it cycles out those older values. So currently, the problems with this is that pressure is very volatile. It was very important that you had good pressure to the sensor, but if you press too hard, it couldn't read through your finger because it uses light to detect these heart rates. And that was solved by some padded tape on either side of it, which allows you to press into it, which is the force that you're expected during working out, and can create a secure grip without pressing too hard. Lastly, converting from just detecting a single pulse to actually converting that into being beats per minute was a more challenging task. Lastly, I was in charge of the power sensing, and this was done just by a voltage divider to detect the current, or detect the voltage, and then because we knew that resistance, we could find the current from that, and then using the resistance of the motor, we could find power. Some of our problems through this was maximizing current, and we ended up going with a full wave rectifier to help with that, and measuring the total power, which we used some approximation similar to early calculus.
Very cool. I was primarily in charge of writing a lot of the system code. I created a new class in the Arduino to track the biometric data and the like caloric and watt hour data into a user for the Arduino. I calibrated the LCD screen and the and a little number pad that serve as a very basic user interface so that somebody can um, input their own data into the machine and see the results without needing to connect it to a laptop or anything like that. The bulk of the time was spent writing the user class. Here I just have the constructor for it, so there's no actual method definitions. But pretty much everything that happens in the code happens through the user class. Most of the member methods will modify the, excuse me, most of the member methods will modify member variables because we wanted to be able to give the option to have multiple users on the same device. So the ability to like access the um, users data like their weight and height that we use to calculate BMI that are used in the calorie calculations was important. And it was a lot easier to create member methods that could be called for the user than it was to create methods that called that try to get those values in the main loop. Um, the little user interface we made is just an LCD screen. It's a 16 by 2 pixel LCD, or not pixel, but 16 by 2 LCD screen. And a little number pad. The LCD screen will prompt the user to put in their weight in feet and inches, and it will their height in feet and inches, and it will prompt them to put in their weight in pounds. And then internally, it will calculate their BMI, and then using that information, it will convert a watt hours to, or it'll measure the amount of watt hours that were generated, and it'll use the heart rate information to estimate how many calories have been burned. We did a lot of interfacing between hardware and the microcontroller, which was not something we had a lot of experience with before this. We had to find libraries for each of the components, so had to wire everything correctly, and then also just setting up the membrane and LCD screens to print out the way we want them to was a bigger challenge than we thought. We also created a new class based on our own specifications. It was kind of the first time we coded something through that wasn't a homework assignment. It was more so meant to meet the needs for our project. So it was kind of cool to sit down and sketch out what we wanted the class to do, what we needed the functions to be able to accomplish, and how we wanted the code to interact with the user. Um, we had some real-time analysis issues in this that were kind of hard to solve because the voltage from the spinning of the hand crank would change so quickly that we needed to kind of simulate a real-time analysis thing on an Arduino. We came to a method called rectangular approximation, which is what Logan was addressing earlier. It's kind of like early calculus where you break it up into small rectangles before you learn how to do like an integral. So we did small averages over 3 milliseconds and summed those together to get total watt hours generated and used that to convert like watt hours to calories. We also had to create some timing structures, just like not so that nothing was delayed in the code because things are changing so quickly. The system needs to be able to calculate those very quickly. In the future, we'd like to add better fittings to the project, to the handle so that it can spin more freely and it has a little more like endurance. It can handle a little bit more stress. We'd like to add some gear shifting capabilities that would make it so we could increase the resistance to just generate a better workout and generate more power with a like gear ratio to spin the motor faster. And we also simulated this without an actual battery. It was just calculations done. So we would like to add a battery to it so that it can convert to real power that can be used. Thank you very much.
Thank you.